In this video, we will learn more on chemical equilibrium. After watching this video, you will be able to sketch graphs of concentration against time to reflect the effects of impulse change to an equilibrium system using Le Chatelier's principle. There are 5 common features on graphs of concentration against time. I shall now name them one by one. Firstly, a horizontal line is drawn to show the equilibrium state of a system. If an external change is imposed to a system which does not affect the concentrations of any species, such as addition of an inert gas, you should draw a horizontal line across the particular period of time. If a non-solid or a non-liquid species is added to a system which contains the particular species, or the gas pressure is increased, a vertical line is drawn upward at the said time, which shows the drastic increase in concentrations of the species. However, if a non-solid or a non-liquid species is removed from a system, or the gas pressure is decreased, or even adding a reactive substance which reacts with a species in the system, including dilution, a vertical line is drawn downward at the said time, which shows the drastic decrease in concentration of the species. An inclined curve is drawn to show the formation of a species of which the concentration increases over time. If a species is consumed, use a decline curve. We shall now solve question 30 from Wei's 2012 chemistry paper together. This equilibrium system is created by dissolving excess silver chloride into ammonia solution to produce a colorless solution with some white deposits. The first key point, where the equilibrium constant, Kc, is greater than 1, hints us that the concentration of product has to be higher than the concentration of reactant. The second key point refers to the time of commencement of the mixture, which is 0. Therefore, the graph has to be drawn from the y-axis onward. In this answer, concentrations of ammoniacal silver ion is represented in blue, whereas for ammonia it is in orange. Let's begin. At time is equal to 0, concentrations of ammonia is maximum, but 0 concentration for the complex ion product since it hasn't been formed. When both the reactants are mixed, ammonia starts to get consumed to form the complex ion over the time until equilibrium is established at E1. Note that the concentration change of the complex ion has to proportionate with that of ammonia, which follows the equation coefficient. Next, concentration of sodium chloride solution is increased by adding concentrated sodium chloride to the system. This impulse change immediately increases the concentrations of chloride ion. Equilibrium is disrupted. To restore the equilibrium, it is shifted to the left to consume the added chloride ion by combining with more complex ion to form ammonia and silver chloride. At E2, the system re-establishes equilibrium with a new set of concentrations in all species. A graph of concentration against time for this equilibrium system is now completed. We shall have another example that is extracted from Wei's 2015 chemistry paper in section 2. You will be asked to continue sketching on the graph of partial pressure against time for an equilibrium of the formation of ammonia. As all species are in gaseous state, the relative concentration can be given in terms of the partial pressure of each gas. In this case, we shall use the same method for the previous part to solve this question. At 8 minutes, the system was suddenly cool and then reached equilibrium again at 12 minutes. Let's apply the 5 steps methods to predict the outcomes of this impulse change. Based on collision theory, when temperature decreases, amount of particle acquiring high energy decreases, therefore lesser collision among the particles. This causes the overall gas pressure to decrease immediately, like this. To increase the temperature, the system promotes the forward reaction, which is an exothermic reaction. More of the nitrogen and the hydrogen is consumed to form more ammonia between 8 minutes to 12 minutes. A graph of partial pressure against time for this equilibrium system is now completed. This video is brought to you by the chemistry team of OSMED. Thank you for watching.